at your topical practice overall. Okay, so this is a consolidation of the topics for this term. First question. Okay, whenever you attempt any open-ended question, it's very important to highlight the key points. Okay, and identify what is the topic. So because this is a consolidated topical practice paper, it is a good chance for me to demonstrate to you. So let's take a look at some of the key points. Mr. Pang conducted an experiment on a fruit tree. He removed only the food carrying tubes at area X on branch A. He also removed both the food carrying tubes and watering carrying tubes from area Y on branch B. So based on this keyword alone, I will know that probably the topics that this question will be on will be transport in plants. Now, there are many things that you can talk about transport in plants. You can talk about water being lost through the stomata. That is a concept. Okay, another concept would include things like what do the different vessels carry. Alright, so in this case, the concept that's being tested here probably would be your water carrying and your food carrying tubes. Okay, which are also known as your phloem and your xylem. So phloem is your food carrying tube and xylem would be your water carrying tubes. We will be using phloem and xylem in this case because it's a lot shorter and it's a more advanced form of the word. Okay, but in exam, take note that it's perfectly fine to use water carrying and food carrying tubes. Okay, now then they tell you that certain key information, fruit Z grows on branch A. Okay, now A, after some time, Mr. Pang observed that fruit Z grew bigger than the rest of the fruits. Explain why. Okay, most of you did pretty well, except that you were missing a few key points. So I'm going to highlight to you, for answering transport question in plants, what are some of the key things you need to consider. So, before penning down the strategy, I want to explain to you what actually happened. Now, they tell you that on branch A, this particular fruit actually grew bigger than the rest of the fruits. Now, they also tell you that only the food carrying tubes were removed. So it's very important to note which area the cut was made. If the cut, okay, was made below leaves, okay, you know that these leaves are still able to carry out photosynthesis. No issue. Okay? They are able to carry out photosynthesis. Why? Because only the food carrying tubes are removed. So water can still travel from the roots up to these leaves. No issue. They can carry out photosynthesis. However, once they have made the food, you need to understand that the food that is made in this leaf here cannot be transported downwards. So instead of going downwards, this excess food needs to be kept somewhere else. So in this case, instead of going down, it goes towards the fruit, making it bigger. This is the logic. Now let's pen down the answer, which I'm going to be a little bit more technical. So the first thing you have to tell me, alright, is to tell me what was being removed or what was being cut at which point. So you have to tell me, since the phloem, okay, or the xylem was removed at which point is this? Area X. So many of you did not tell me which area. You just told me that the water carrying tube was removed. That's it. Are you talking about area X or are you talking about area Y? You need to be specific because there are two areas. Okay, and that's where you will lose mark. So area X. Thus, food made by the leaves could not be transported downwards or below area X. Okay, this is the second key requirement. So first requirement tells me which part is being removed. Second requirement tell me cannot be transported where. So since it cannot be transported below area X, it can only be transported above. The next key word is very important. More food is being, okay, tense, so we want to be accurate. More food was transported to fruit Z, making it bigger. Now, the next thing is very important. This word, more food. Because whether you make the cut or not, whether the xylem vessels or the flow was removed, you will transport food to the fruit. Sorry, I just realized I made a very serious error. Please, this is your phloem. Yes, my apologies. Okay? Over here. Please be careful. Okay? So, because the phloem was removed, food cannot be transported below area X. It would then go to fruit Z. However, the word more needs to be there because whether the phloem was removed or not, food will be stored in fruit Z in any case. Just that now it's more. So this is very important. Alright, it's the same concept as the concept that we talked about when it comes to your respiration rate when you exercise. So remember, digested food and oxygen, they are being transported to your cells all the time. However, when you run, more of it is being transported. Same type of thinking, okay, that you need to employ. Next, explain why branch B withered and died more quickly than branch A. So let's compare. Alright, they both receive a cut. What is the difference? So if you notice, the difference now is that both food and water carrying tubes are removed at this area here as compared to area X where only your food is being removed. So if you ask yourself this question, why would a plant die? A plant would die because it doesn't have food. Okay, it's the primary answer that you should know. And why is food important? Because food is required for respiration. Right? So in this case, because there's no food, why is there no food? Because water cannot be transported, okay, from your roots to branch B. So all the leaves there are not able to carry out photosynthesis. Eventually there will be no food for the branch and the branch will die. So you need to answer that. Okay? So you would say that since both the phloem and the xylem were removed at area Y. Next point. Leaves on branch B cannot receive water from the roots. Next point. Hence, the leaves on branch B are not able to carry out photosynthesis and the branch dies without food. Right? So I mentioned before that photosynthesis is equivalent to making food. So if you don't use the word photosynthesis, you use the word make food, is perfectly fine. You will not be penalized. However, we learned the scientific term. When I teach you the higher level. Okay, up to you. Right? So it's very logical, the sequence. So you need to be very specific and it needs to relate from one point to another point. So it's because the branches are not able to photosynthesize, make food, no respiration, no energy, and the branch dies. Okay? Now, if I were to stretch it one step further, and I say now the cut is going to be here, instead of at the branch, I put it at the trunk. And I tell you that both the food, okay, or rather, both the food and water carrying tubes are removed, the whole tree will eventually die because all the leaves will not receive water to make food. The whole tree will eventually die. Okay? Just so you know. Next, Naomi set up an experiment to find out if the amount of carbon dioxide affects the rate of photosynthesis of a plant. So right off the top, I already know. I see the word carbon dioxide, I see the word photosynthesis. The topic of this question must be on photosynthesis probably. And remember, when it comes to photosynthesis question, I cannot stress this anymore. You should always write the word equation at the start of the paper. Confirm one, don't need to see already. Be it SA2, prelims, P6, the first thing you do when you get your piece of exam paper is to pen down the word equation for photosynthesis and respiration. And using that, you would be able to logically deduce an answer. Okay? So the concept that is being tested here is also pretty obvious. They tell you already, amount of carbon dioxide. So they're testing you on factors affecting rate of photosynthesis. So without even looking at the question, straight away I know, okay, based on my word equation, I know I need water, I need sunlight, I need carbon dioxide. So these three, together with amount of chloroplast or chlorophyll, is going to affect the rate of my photosynthesis because I need these items to photosynthesize, right? So before I even read, I already know already, all these things should be in my mind. I'm thinking out loud for you so you know how my brain is processing things. Okay, then they tell you, she added 10 grams of substance Q in the water. Substance Q increases the amount of carbon dioxide in the water. So with this statement, I should also know that as substance Q increases, rate of photosynthesis should also increase based on theoretical knowledge. Okay, without even looking at the rest of the question. Okay, I'm not saying that you should just jump to answer it. I'm just saying that these are the things that should flag up in your mind. She then counted the number of bubbles produced, okay, by the water plant in 1 minute. The bubbles contain oxygen, very consistent with our theoretical knowledge because we know that in photosynthesis, oxygen is produced. Naomi repeated the experiment by adding different amounts of substance Q. She recorded her results as shown. So without even looking at the results, you should know the more substance Q, the higher the rate of photosynthesis. However, I want to stress, there will come a time whereby if you keep adding substance Q, your number of bubbles will no longer increase because the rest of your factors that are needed could be in limited amount. For example, you may give a lot of carbon dioxide, but if you don't give enough water, or you don't have enough light, or you don't have enough leaves, okay, which stands for your chloroplast, it's just going to be stagnant. That's it. Okay, so like what is happening? So amount of substance is your change variable. Number of bubbles is your measured variable in the experiment. You will notice that as this increases, this also increases. Okay, in exam, it is very important to write this down. You may think, oh, why am I writing increase and increase? This is to help you make sense of data. Now, what is the relationship between the amount of substance Q added to the water and the number of bubbles? Very straightforward because you have already indicated over here. So the answer would be as the amount of substance Q added to the water increases, comma, the number of bubbles produced increases. Now, be very careful. The cause and effect needs to be in the correct arrangement, in the correct order. You cannot say, as the number of bubbles produced increases, the amount of substance Q added to the water increases. No. Okay? The cause and effect is not interchangeable one. Okay? That I've mentioned before. Now, doing photosynthesis, what does the plant produce other than oxygen? Glucose. Now, I want to stress that food is not good enough. Okay, I want you all to step away from answering food. Use the word glucose or sugar. I will accept either one of it, but not food. Okay, this will help you distinguish later on when you are doing your respiration. Because a lot of students use the word food. Then when they are asked what is needed for respiration, they also write down food, which is not correct. It has to be digested food. You realize that? And digested food actually is glucose, what your plant initially has produced. So if you are consistent by saying glucose, you will also know that in respiration, you will use glucose or sugar. Glucose is a type of sugar. Alright? Next. Other than using the same type of plant, state two factors Naomi should keep the same in every setup to ensure a fair test. Basically everything, except the change variable. And don't tell me the measured variable. This is the measured variable. The measured variable is something that you cannot control. It's independent. It depends on the experiment. That's it. Okay? Whatever you obtain for the experiment, okay, you cannot control one. So everything else except the amount of substance can be listed as an answer, provided you give a quantifying term. For example, please don't tell me things like test tube. Are you talking about the thickness of the test tube, the brand of the test tube, the color of the test tube, the type of the test tube? Okay, next, don't tell me location. I've told you all many times, do not put location. I still get somebody writing location. Now, why location cannot? I'm going to stress once again. So the classroom is a location, right? So if you say, oh, conduct the experiment in the same location, but one is on the table, one is under the table. So you turn on the ceiling lights. Straight away, the one under the table will receive less light. Agree? So because of that, you cannot put location. Absolutely not. Unless you really ran out of ideas, but I'm pretty sure you can do better. So what are some of the things I accept that I think would be good? Okay, would be light intensity. Now, many of you have chosen to use the word amount of light, amount of brightness, etc., etc., etc. I've told you this before also. The correct term to use to describe the brightness of light would be light intensity. Learn this correctly, because when you go on to secondary school, this is what is needed of you. Okay, so light intensity should be the same type of test tube. I will accept. Okay, volume of water. Okay, look at the quantifying term that I'm using. Volume of water. Please don't tell me amount of water. We need to step away from using such general term. You can even say temperature of water. That's fine. Okay, but have a quantifying term. Next, other than increasing the amount of carbon dioxide in the water, state another way to increase the rate of photosynthesis by the water plant. So, ask yourself, what are the factors needed? You cannot change the water plant. So you don't tell me put more leaves, stick more leaves on the water plant. You can't do that. So think of other ways. So they say you cannot increase carbon dioxide already. So you cannot say put more substance Q or put more carbon dioxide. No. Or put more baking soda. No. Because baking soda will increase carbon dioxide also. So then you are left with light and water. But the plant is already submerged in water, right? So you can't really add more water, it wouldn't make sense. So you're only left with one possibility, which is to increase light intensity by using a higher wattage or using a brighter lamp. Now, because they state another way, this is like asking you how. So it needs to be an action. So remember, I told you this before. There is an explanation part and then there is the action part. So there is the first part over here whereby you increase light intensity. And how do you do that? You use a brighter lamp. Or it can be the other way around. Use a brighter lamp to increase light intensity. Okay? Follow this way of answering. Always tell me an explanation and then the action. Okay? Next. Okay. John set up an experiment using identical batteries, wires, and iron bars. Now, they usually put this kind of statement here, okay, because they don't want you to think too much. Students tend to think too much. So the question will put this there to narrow your scope of thinking. Okay? A steel nail is freely suspended in an equal distance between iron bars A and B. Okay, steel nail. They purposely put the word steel there for a reason. So when you read a question, don't just jump in the answer. Ask yourself, why would they put the word steel there? Okay, there must be a reason. So then you need to ask yourself, okay, steel, which concept did I ever come across of this material very explicitly? You will realize that it's actually magnetic. Right under magnets, you know that steel is a magnetic metal. And coupled with iron, straight away it will hint you that, okay, probably this question has got to do with electricity because I see batteries, I see wires, and it also has got to do with magnets as well. Okay, then they ask you in A1, what would happen to the steel nail if both switches X and Y were closed at the same time? So when this is closed, you always need to trace. I've told you many times. When it's closed, you have to trace and see what will happen. So if you trace it, you will realize that this is a closed circuit. It's a complete circuit. And then after that, this over here, because it's coiled with a wire, based on your understanding on magnets, the topic magnets, you know that this will become a magnet, an electromagnet. Then you trace for the other side and see what happens. Okay, so this is also closed, and this one also will become an electromagnet. Now, then after that, ask yourself, what is the difference between these two circuits? You would notice that one has 10 coil, one has 20 coil. Okay? So, how does it affect your magnets then? This becomes a stronger magnet. Also, you will notice a second difference, which is the number of batteries. In circuit Q, there are 2 batteries, which means that more electric current is flowing through as compared to 1 battery. So definitely, your circuit Q will produce a much stronger electromagnet, okay, out of your iron bar B. So what will happen to the steel nail if both were turned on? So both are actually electromagnet. However, your steel nail will go towards B because it's a stronger magnet. So you have to tell me what happened. So straight off, very simple, the steel nail would be attracted to iron bar or bar B. Because there's only 1 bar, so it's fine to just say bar B. Now, next very importantly, some of you, instead of telling me iron bar B, you tell me the steel nail will be attracted to circuit Q. That's not correct. I might have given you correct, but it's not, that technically it's not correct. Because it's not the whole entire circuit that is an electromagnet. It is your iron bar only. But if you say it will move towards circuit Q, that's fine, that's spectral. But if you say it's attracted to circuit Q, that is theoretically not correct. Okay? Now this part is important. You have to use CEO to answer. Okay? So you will need to say that both becomes an electromagnet. However, one has more. So that's where you need to put in that differentiation. So I'm going to show you that. Okay? So you will say that when both switches are closed, both circuits are complete. And electric currents can flow through both circuits. This causes both iron bar A and B to become electromagnets. Okay, this is the outcome part. However, as there is more, or there are more coils around, wire coils to be specific. More wire coils around B than A. Iron bar B is a stronger electromagnet. Than A. Okay? So there are two ways to answer this. Either you talk about more wire coils, or you talk about more number of batteries in circuit Q. So you need to be very careful with your English also. You cannot say there are more batteries in iron bar B. That doesn't sound correct. Some of you wrote that. So if you are talking about batteries, you have to say more batteries in circuit Q. Alright, so therefore more electric currents now passes through your iron bar B, making it a stronger electromagnet. Now also take note, whenever, this is very important, you want to talk about number of coils, you must tell me where are the coils. You cannot just say more coils. You must say more coils around the iron bar. Iron bar what? Depends on the question. But this is very, very important. Okay? So I'm going to mark up for you. So this would be your C. This would be your E. And this would be your O. C, E, O. Okay, moving on. Okay. Next question. John set up another experiment as shown below. Iron bars A and B now have equal number of coils or wires around them. So now the wires are same. What's remaining different? Which is actually the number of batteries. So circuit Q still has more battery than P. So then they ask you, would the results be different from the first experiment? The answer would be no. Now for this type of question, right, the minute you answer the first part wrong, the second part explanation straight away is 0 marks. So this type of question, you need to think very carefully before you make your claim. So the answer is no, because circuit Q still has more batteries. So more electric currents is still able to flow from the battery, making this electromagnet stronger. Okay, so answer would be no. Okay, as circuit Q still has one more battery, or you can just say more batteries, doesn't matter. One more battery then circuit P, more electric currents will flow through the circuit, making iron bar B a stronger electromagnet than A. So what is key here is that you need to tell me more. Some of you just went, circuit Q has 2 battery. So what it has, so what if it has 2 battery? You didn't tell me that it has more. Okay? So you need to make sure that you have that comparison there. Don't just tell me it has got 2, so what? So 2 means one more than the other, right? And that's where a lot of you lost the marks. Okay? And what does one more mean? One more means that it has more . Okay? Can? Moving on. Next, the diagram below shows a light bulb. Indicate with a tick if parts A and B are conductors or insulators or electricity. Okay, this is very straightforward. A cannot be a conductor of electricity because if not, every time you touch a light bulb, you get electrocuted. Okay, and also if you want electricity to flow only in the metal wire parts of it, then obviously this part cannot, A cannot be a conductor. So insulator, and then your B needs to be a conductor. Alright? So once again, I want to stress, remember how the wiring works. Let me use red color. So one of it actually touches, why isn't this red? Okay, one of it actually touches the side of the metal casing. And then after that, it runs across, and the other goes down. Okay? So when you connect anything, any wire, one needs to be at the side, one needs to be at the bottom. Just in case you all forget. Okay? Next. Now, bulbs W, X, Y, and Z were connected in a circuit as shown in the diagram. What would happen to bulb W when bulb X fuses? Explain your answer. Okay, so because so once again, when I talk about this, I always say trace. You need to trace. You have to trace. So from here, where's W? W is here. So because W and X, these two are arranged in a series. When one fuses, it will cause an open circuit for the other. Because they are arranged, these two, they are arranged in series. Okay? So therefore, you have to say W will not light up. Okay, then you explain why. So as W and X are arranged in series, when X fuses, it will cause the circuit to be open. Okay. electric currents can no longer flow through the circuit. Okay, so where is your CEO? So in this case, you put the O at the front. Okay, and then your C is here. And then your E is here. Okay? Now, it is important to talk about the arrangement, because I told you the last time round, there are parallel arrangements and there are series arrangement of your bulbs. Whenever there are questions like that, you have to mention the arrangement because it affects the outcome. So if you take a look at this, you will notice that W and X are arranged in series. However, Y and Z, they are parallel to each other. Okay? So then the next question asks you, would Z remain lit if X was removed? Your answer would be just yes. That's it. But if you were asked to explain why, then you would need to say that because, okay, X and Y are arranged in a parallel arrangement. Hence, if X is removed, Y still has an alternative pathway, or the circuit for Z is still complete, and electric currents can still flow through. Right? You need to be able to tell me that. Okay?